Okay.
Right, we are officially alive, and we have Professor Clive Neal, based in the US, but I detect he's got a different accent to the regular American academics. Whereabouts are you from?
I have been accused of being from South Africa.
I would have thought maybe, but I pick up an English accent.
Yeah, you do. You do. But in America, it's Australia, New Zealand, New Jersey, or South Africa. But I'm from Southern England originally.
And if I recall reading something about you, you are a long-suffering fan of a certain football team.
Yes, I am. Ipswich Town. Oh, boy. Yeah, don't ask. It's a real football team, not American football.
I love it. I love it.
Which is really catchable. So.
So now, I mean, you obviously studied in the UK, or you studied in the US. How did you land up getting to the US? And we want to try and put some sort of map together on your trajectory of how you got to where you are today.
Okay. Always knew I wanted to be a geologist. At the age of 5, that was it. Everything from 5 onwards was to become a geologist. So went through school, did everything to go to university at the University of Leicester in England, did my undergraduate there. Then there was a fork in the road. Do I join the army or do I do a PhD? So I had my interviews for the Royal Engineers. I was going to join those, and my only criteria for the PhD was to get a field area as far away from England as I could without leaving the planet. And at the last minute, a project came up, and I ended up doing a PhD at the University of Leeds, with my field area being in the Solomon Islands in the Southwest Pacific. After that, I did a temporary lectureship at the University of East Anglia in the UK. And then I got a job I never applied for. I ended up being offered a 2-year postdoc in Knoxville, Tennessee, University of Tennessee. And I never applied for it, but I ended up getting, I get this letter in the mail, and it was quite 2 years in America. That'll be fun. But that was 1986. It's now 2019. And I did 4 years at Knoxville and then got a job at University of Notre Dame up near Chicago, which is where I am today.
But now, you said when you were 5 years old, you knew you wanted to be a geologist.
Yep.
How could you have been so certain at 5 years old?
Rocks were absolutely fascinating. I had collections of rocks from 4 and 5 years old, and I wanted to know more about them. So I did a bit of reading and figured out that I wanted to be a geologist. That's what geologists do. So let's go do it.
That is incredible.
Initially, it was going to be a paleontologist, but when I went to university, my paleontology teacher was just so boring. It sort of put me right off. So I ended up switching to igneous petrology, volcanology. So that was.
So you know something about volcanic rocks.
Yep.
And then you also had a passion for space and the moon. Well, how did that come about?
When I went to UT Knoxville, 20% of my postdoc was studying Apollo samples. So I studied Apollo samples, and I thought, these are really cool. And so that I switched it around. So 80% of my postdoc became Apollo samples and 20% mantle rocks from the Earth. And then when I got the job at Notre Dame, I continued my research into that. It's been ongoing now for 33 years coming up. Now I'm getting more and more involved in space policy, which is politics. I'm not very good at that. But it's a fascinating subject, and I want to see the 13th human walk on the moon. I saw the first 12. I want to see the 13th.
And I mean, right now, the moon, well, it was a hot topic, and then Mars was a hot topic, and now Mars is put on the back burners and the moon's back to being a hot topic again. Why is there so much ambivalence and indecision about the moon?
Politics. Number one, we can't go to Mars right now. We send humans to Mars, you're going to kill them. There's no point in doing a return trip. They're going to be dead before you get there. So there's two things. We've got to learn to live and work successfully in space, off planet, not in the Earth's magnetosphere, because you don't get the full space environment. The other thing we've got to do is we've got to develop a space architecture that is destination agnostic. This moon, Mars BS that I've heard going on practically all my career, it's not a competition. It's a way to get humans beyond low Earth orbit, onto the moon, onto Mars, and to do it sustainably, frequently, and permanently. So that's the goal here. Is it's not a moon or Mars thing, and it's something I made at a what would they call it? Achieving Mars workshop. I was invited along to give a talk there about how the moon could be useful to get to Mars. But I read some of their previous reports when the moon wasn't now politically correct again. And one of the findings was that they found the moon had absolutely zero value in getting humans to Mars. So I put this finding up on the screen and said, now, before we go on, do you really mean this? Because if you do, I'm going home. There's no point in me being here. And the person who wrote it went bright red and accused me of misquoting him. And I said, cut and paste does not misquote you. So that broke the ice for that. And we actually had a very productive meeting about synergies between the destinations, rather than, well, we got to if we go to the moon, we'll get distracted. And that's just completely wrong. If we go to the moon, it's going to enable so much more.
Sure. And I mean, you obviously have worked with the Apollo rock samples. Are you still learning new things about them, or have you pretty much? I mean, you've exhausted all the chemical tests and the physical tests that you can do with them.
Let me give you an example of why the Apollo samples are important. 1971 and 1972, Apollo 15, Apollo 17 brought back volcanic pyroclastic deposits. 2008, we finally had the technology to show that they contained water. These beads in the interior had endogenous water. It was from the moon. It was ready to be used, if you like. But it changed the paradigm about how we thought the moon formed, how we thought the moon evolved, and what the role of volatiles were. Because after Apollo, we thought the moon was bone dry. So now we've got orbital data to show these pyroclastic deposits contain water, and they're quite thick deposits. We now have a resource that can be used for life support and can be used to create rocket fuel. So this is something that was a paradigm shift 47 years after the samples were actually returned.
So now you sitting there, you discovered these things. You obviously get overexcited because you know what these things mean.
Oh, yeah.
When you go and articulate this to the rest of the world, do people show the same passion and enthusiasm, or they're like, no big deal?
Some of them do. Depends whether or not people who come here, my public lectures, are normally interested in space. Mm-hmm. All right. So you're preaching to the choir. But it's politicians are the ones that need to get excited about it, because they're the decision makers. Unfortunately, a lot of them don't have the educational background to sort of grasp the importance of this. So it's an uphill battle, but it's one I think we're making inroads into, and it just means that you've got to keep your message simple, keep it to the point, and be ready to answer questions when they come.
Well, talking about questions, we've got quite a few people from different parts of the world that have joined us. Right. I know some of them might have to leave quite early. So I know, Mr. McNulty, you mentioned that your group had to leave early. Are there any questions from your side?
Oh, yes, we have a student right here. Why don't you tell us your first name, and your camera's right here. Come on over. Are you ready? Yeah, let's see it.
Don't be shy. Don't be shy. Come on now.
Go ahead.
Where have you visited?
Where have I visited?
Like as part of your research, maybe.
Oh, I haven't been to the moon. I'd love to go, but I'm too fat, so I won't make it. They're going to need a bigger rocket if they send me up there. Where have I visited? That's a good question. Wow. Solomon Islands, of course.
Where?
Solomon Islands. You have to read an atlas. If you're in America, then you won't know where that is. But you have to read an atlas. My kids were educated in America. So,
and I mean, if you're going to go do your research, you obviously went to the Solomon Islands because you were doing your thesis or your doctorate there. But I mean, when you go to other parts of the world, do you just go look at rocks and get excited about what you see? And
yes, absolutely, absolutely. I've been doing a lot of work with the Scientific Ocean Drilling Program to study supervolcanoes as well, and that's something that we've got these huge. Maybe the largest volcano in the solar system. Everybody thinks it's Olympus Mons, but in the Western Pacific, there's a volcano.
An underwater one, isn't there?
Yes. Tamu Massif on Shatsky Rise is one that rivals Olympus Mons, and it's on our planet. But we have to use it's underwater now, but we have to use ocean drilling and sonar to actually understand it.
So now I know you also have a passion for the ocean, so we are going to get onto that.
Yep.
But what I find fascinating is that people talk about the moon. It went quiet for a decade or two, and then all of a sudden, I could see that our young lady would like to carry on with her question. Did you want to ask something else?
Yeah.
I'll go back to my question.
There's a follow-up, I'm afraid.
Does like the rocket ship size like matter on how long it takes?
Oh yes, because how much fuel can you take? 90% of rocket fuel is to get out of our gravity. So you need a bigger rocket if you're going to go further, because you need to get back as well. So how do you create a rocket to do that? Well, you go to the moon and you refuel at the moon, and then you go to Mars with a full tank so you can come back. So it's a way of using the moon to enable Mars.
And are you confident from a refueling point of view that the moon is going to be able to make it happen?
Well, there was a paper that came out right at the time of this Achieving Mars workshop that showed that in the polar regions of the moon, there was up to 38% water ice at the surface of some of these permanently shadowed craters.
What?
Yes.
But we don't get to see that, though, because
Yes,
we only
do.
see one side of the moon.
We have Lunar Reconnaissance Orbiter that is up there doing a polar orbit that is sending back the data, and the intersection of data sets shows conclusively that we have a resource there. The issue is that they're some of the coldest places in the solar system, maybe 20 to 40 Kelvin. So what is that? Minus 250 Celsius. So it's a bit cold.
And obviously China have launched a lander on the moon, on the dark side of the moon.
No, stop.
Not the dark side of the moon.
It's the far side.
Ah, the far side. Well, why would they call it the dark side?
Because of Pink Floyd. So, and a lot of people don't understand that, but that's no. It's when we have a new moon here on this side, and we see just a sliver. It means that it's daytime. It's very light on the far side. So it's the far side, and it's the popular press grabs hold of this. Oh, they've landed on the dark side. Well, how do you land in the dark? They didn't land in the dark. They landed in the daylight. So I mean, it's so yeah. They did. There was a world first, and this is absolutely amazing. And now they're going to do a near side sample return later this year, a robotic one, and then they're going to do a South Pole sample return, and then they're going to do a robotic mission as a precursor to understand how difficult it would be to put a lunar base at the South Pole.
Wow. Okay. I noticed we've got a group in Jennifer's room. We've got two Jennifers, but I'm assuming that they are both different Jennifers. So let's go with the first one. I think we've got a whole bunch of students over there. Do you have any questions on your side? No? They're very shy. We'll go to the other Jennifer. We have two students over there.
Are you this one? Because they're like the same.
Oh, they're all the same. Okay. Would you like to ask a question?
With a bunch of Chromebooks. My question is, since there has been shown water on Mars, could you possibly fuel up on Mars and then launch back to the moon, then launch back to Earth?
You could you would set up similar processes because we, as I say now, water is the oil of the solar system. We've got it on the moon, we got it on Mars, we've got it on asteroids. So part of my push is to get a study going to develop this similar technologies for different destinations. So once we've developed that technology for the moon, we can send it to Mars, we can send it to asteroids. So the only issue is that some rocket companies don't want to use liquid oxygen and liquid hydrogen. They want to use liquid oxygen and liquid methane, and this is SpaceX. So I've been having few arguments with SpaceX saying that you're missing the point, but they think they can bring everything from Earth. To me, that's going to be non-sustainable. But I'm just a geologist, not a rocket scientist. But I think that we've got similar resources on Mars, similar resources on the moon. Why not? We have the potential to make this happen.
How closely are you working with the Chinese and the information? And first of all, how are they going to get those samples back? Because as you know, getting rock samples from any place, whether it be a planet, well, I know that they're going to be trying with the asteroid. They're going to try and bring the sample back. Or have they already succeeded? I mean, there was a plan to do that.
Well, you've got two asteroid missions, Hayabusa 2 and Osiris
Rex, yeah.
And they're both getting ready to make their sample collection. But you've got to remember that the Soviet Union did 3 robotic sample returns from the surface of the moon in the 1970s.
What?
So,
how come we never heard about that?
Well, because they brought back less than a kilogram, and Apollo brought back 382 kilograms. So there's not many samples, but yeah, this is, you're basically 60s technology can do a robotic sample return from the moon. So now China is going to become the second nation in the world to do a robotic sample return from the moon. US has never done it from a planetary surface yet. Maybe Osiris Rex will be the first.
That is quite an incredible development.
Yep.
And of course, not just obviously samples of rocks, but soil. And as a geologist, you also look at the soil and that type of thing as well.
Oh, well, they'll be bringing back the regolith. They'll be bringing back the unconsolidated material on the surface. They won't be bringing back hand specimen size samples because it'll be a scoop and a fill and a return.
And does the depth make a difference in terms of the quality of the sample?
Depends on where you are on the moon. We don't know. They're going to a place we've never visited before, so we don't know. So it'll be interesting to see. We know that there is variation from the Apollo deep drill cores. And it depends how much material has been thrown out from impacts on that site. Micrometeorites come in and grind up the material to give you that very fine regolith, so you get a nice perfect boot print, as you saw from Apollo 11. And the other interesting thing is we can still see the astronaut tracks from orbit present day, so they're still preserved up there. But the major impacts will bring material from outside on top of that particular area. So it depends how much impact action has been going on to just how much variation you'll get with depth.
One quick trivia question, maybe you know the answer. What color is what is it now? What color now is the original flag that was planted on the moon? Well,
I imagine that it's white and it's been bleached, but a lot of people thought it would be gone, but we've actually imaged the shadow from the flag from Lunar Reconnaissance Orbiter camera. So the flags,
it's still there.
The flags are still there. But whether it's red, white, and blue, it's probably all white now and been sun bleached. But just goes to prove that nylon is pretty tough.
That's incredible. So now we're going to go all the way to India. Hari Krishna, do you have any questions you want to ask?
It's a great pleasure. It's really great pleasure to meet one of the greatest scientists in the world.
Oh, I don't know about that. Who are you talking about?
Yeah. So here is my question.
Oh, we lost him for a bit there. You're going to have to repeat your question.
Yes, she's going to ask her. Do you think that life on Mars is possible? Do you think, Mr. Scientist, do you think the life on Mars is possible or not?
I think life on Mars was possible. I don't know whether it is now. If we look at what we've learned from Mars about flowing water on the surface and having ponds and lakes and standing water on the surface, then I think definitely we can expect that life may have evolved. We found some evidence of organic molecules, but they could be abiotic, i.e. not life, not due to the presence of life. And that's the Mars Curiosity recent finding. But it's certainly intriguing to think that there could have been life evolving on Mars early in its evolution, when the atmosphere was thicker due to volcanic activity. Water was certainly stable on the surface of Mars. So that's what we see down here. You need heat, and you need nutrients, and you need water. We go to our mid-ocean ridges, and we can see that around the hot areas and the ridges, life is abundant. So we use that analogy with Mars to look in those areas that may have contained standing water, lakes or oceans, to then explore for at least fossil life rather than life that is still present. And if life is still present, it will not be at the surface. You would have to drill deep for that.
So you obviously have no expectations of any creatures being discovered. It's really about evidence that they were, as opposed to proof that they are.
I don't think we can discount the fact that there could be life on Mars now. I think that it's obviously not flourishing, that's for sure. Otherwise we would see it at the surface, but we know in terms of life as we know it, the surface is very toxic to life. So I think that we have to start with the evidence of fossil life, if we can find that. And with the orbital data sets for Mars, we certainly know where on the surface to go to look for that. And that's why Curiosity it landed where it did. The clay minerals that are present there are certainly indicative of an environment at that time that would have been hospitable to life.
And now, obviously, InSight, is enjoying its time, but with a lot more advanced technology to try and send data back about the samples they're finding. What sort of things are they looking for now on InSight that they couldn't find on Curiosity?
InSight is a geophysics mission. It's looking for Mars quakes. It's trying to understand the interior of the planet and the type of activity that is currently going on Mars. Now, we learned from Apollo, Moon is much smaller. There are lots of moonquakes that go on the Moon.
What sort of magnitude?
Up to about 5.5.
So that's quite big.
Oh yeah, and the maximum ground motion lasts for about 10 minutes, not a minute or 30 seconds as we get on this planet. So if you're at the epicenter of one of those, you really don't want your moon base there. So we need to understand where these high magnitude moonquakes come from. But on Mars, we don't know. We assume that there are Mars quakes because Mars is a bigger planet than a planetary body than the Moon. So we assume that there will be Mars quakes. But this is a Pathfinder geophysics mission to actually set the baseline of, yes, there are Mars quakes, and we sort of get an idea of their magnitude, but you need a network of seismometers to actually locate them. Apollo could do that, but it had a very narrow network, all on the near side in the center. So my goal is to reestablish the Lunar Geophysical Network to fully understand the interior of the moon. And eventually that will be the goal for Mars, to understand the interior of that planet. So this is a very different mission from Curiosity, which is roving around the surface, looking for evidence for fossil life and maybe extant life or current life, whereas InSight is a geophysics mission looking at the interior of the planet.
I see. And I mean, so if we obviously have Earth or moonquakes, that would imply that there are plates or faults happening beneath the surface.
Now, the moon is a one-plate planet, as is Mars. There's no plate tectonics on Mars. There is no plate tectonics on the moon.
So then, what causes an Earth? I mean, a Mars quake or a moonquake?
Well, exactly. So a lot of it is on the moon. One category is tidal attraction. As the moon goes around Earth, the Earth exerts a force on it and causes it to sort of fracture. And these are deep moonquakes. They about 1,000 to 1,700 kilometers within the interior, and they occur regularly. And each nest has a distinctive seismic signature, and it's quite bizarre to see them. And they have periodicities in their activity. Another one is meteoroid impacts, where you can see the impacts coming in with flashes, but that also sends a seismic energy through the interior. Then the smallest ones are when you go from lunar night to lunar day. There is such a temperature swing that you actually cause expansion and contraction of the surface that generates seismic energy. And then the shallow moonquakes are the ones we just don't know. They're the biggest ones. There was at least one a year of magnitude 5 or greater during Apollo, and we don't know what causes it.
And none of the Apollo astronauts were on the moon when there was a moonquake to relate the story.
There may have been one, but some of these are very small. These seismometers, the Apollo seismometers, were vastly more sensitive than what we need on Earth. So yeah, there probably were, but they just didn't feel it.
Wow. Now I know we have we had someone from Russia. She has disappeared, but hopefully she'll pop back in again. And we had Govinda in Nepal. But if there are any students in any of the class that would like to ask a question, just stick up your hand, and then then unmute yourself. And okay, you got another question? Go for it.
Is it possible that you could raise some plants, and as they rot, it will produce methane, which you could liquefy and use as a form of fuel?
You would need a lot of plants. I mean, a lot. If you look at the deposits on Earth, if you take coal, I think it's a factor of, if you find a coal seam that's a meter thick, it would take, I think, 15 meters of plants to actually create that coal seam. And again, when you're dealing with oil and gas, you need a lot of material to accumulate. So that would be I would call that something that would need probably terraforming of Mars in order to achieve, but we don't even do that on this planet right now.
I mean, I've got a solution. We just take 5 cows with us. You'll get enough methane gas to keep you busy.
There you go. Just take the cows with you. But
the Aussies and the South Africans, the English and Aussies and South Africans, we all understand that cows definitely make a huge difference.
Yes, they do. Yes, they do, and that is unfortunate. But no, I think the idea of the methane has been detected on Mars, and we know that it's seasonal, but it is minute compared to the water reserves that we have. So liquid, and when you look at the actual chemical propulsion effect, liquid hydrogen has a much greater propulsion factor than liquid methane. The problem with hydrogen is that it's difficult to store. Mm-hmm. It's very volatile. It will escape. It's very small, so it gets through all sorts of cracks. But my solution to that is, well, you just store it as water, and you split the water when you need it, so you don't have to store the hydrogen. I mean, to me, that's, well, it does to me, but hey, geologist, not an engineer. So I think you have to, you think it through. We know water's pretty stable, and we know how to keep that contained.
Okay. Bonnie, do you have any questions? I know you have students coming in and out. No questions. And Govinda in Nepal, do you have any questions? Sometimes people are a little bit shy. I've got lots of questions. Let's have a look. Oh, I see Harry's got a question. Go for it. So you just have to unmute yourself. There we go.
I'm not hearing anything.
I'm not here. No, there we go. He's unmuted himself. Yeah, go for it, Harry.
Yes. So my daughter is asking a question that do plants exist on moon? Is it possible?
They don't exist on the moon. Is it possible? The Chinese Chang'e 4 mission showed that it is possible for them to germinate. Unfortunately, they didn't keep the plants warm when they went to lunar night, so they all died due to frostbite. They got frozen out and died. So we know that that was the first experiment to actually show that Earth plants could, or seeds could germinate on the moon. Now, this was a very controlled experiment, but will they grow in lunar regolith? There was some experiments done during the 1970s at Johnson Space Center to show that plants could grow in lunar regolith, but they didn't use pure lunar regolith. They mixed it in with terrestrial soil. So that was more of a toxicity experiment to see if the plants would die due to the effect of lunar regolith, and they didn't. It wasn't to show that they could actually grow. So no experiment has actually been done using pure lunar regolith to grow plants. This is going to be important and critical if we're going to have a permanent human presence on the moon.
I can imagine. I mean, and why regolith, not moon soil or moon?
Oh, sorry, I'm a
rock?
purist on that. Soil means it has organic matter mixed into it. If it's just a mixture of rock particles, it's regolith. But soil is what people know. But if you say soil to me, well, we can grow stuff in it. We don't know about the regolith on the moon yet. So that's why I call it regolith. It doesn't have any organic matter.
Now the Humans to Mars Summit, which is coming up in May, are you going to be speaking there at all?
I'm on the program committee, and I think I'm on a panel at some point in time. But my travel schedule is a bit interesting. I hope to be part of that. But it's gotten crazy. But I should be there.
Well, do you think that, looking at the changing of the guard, that the motivation to go to Mars is different to where it was 5 or 6 years ago, for example?
That's a good question. I think the zealots for Mars haven't changed a bit. They want to go straight to Mars. And the thing is, those people are very, very selfish, because if we go straight to Mars, we may be able to do it, but I still think we'll kill astronauts, and then it'll be the end of that.
But if we do it in 20 or 30 years, maybe, but if we do it in 50 years, by then we might have, ironed out all the bumps.
Let's think it through. We need to learn to live and work off planet. We actually have a laboratory in our own back garden called the moon. Mm-hmm. Why don't we go there and figure out that we can live and work off planet? Because if we can live and work on the moon, which is close, we can certainly live and work on Mars, where you don't have such high temperature swings between night and day. You have some insulating atmosphere, not much, but this is how the moon can enable Mars. And that's why I become, I accused him at the Achieving Mars workshop of being selfish because you wanted it in your lifetime and you may not see it. And the thing is, our job is to set it up so these young folk can see it. And it's to put it in place, something that is sustainable, not like Apollo. Apollo was great because it showed us how not to do human space exploration. And we need to learn from history, otherwise we'll repeat it. So what we got to do is to look at the sustainability of this. And the sustainability of any program such as this is the creation of jobs. So right now I teach a class at Notre Dame called Living and Working on the Moon. My conclusion is that this is science fact, not science fiction. It needs political will behind it in order to make it happen. But we put in practice, if you can show a return on investment from any government program, i.e. you're going to create jobs in the private sector, your decision makers are going to love it, and they're going to go with it. And it's to show that that growth in those jobs. So I used to chair the Lunar Exploration Analysis Group, and we put together a commercial advisory board that we started off with, I think, four companies. In the last 4 years, that is now up to 43 companies. So there's a lot of interest in the commercial sector about the moon. NASA's announced its Commercial Lunar Payload Services program, where it's paying companies to deliver payloads to the lunar surface. First launch is supposed to be this year. Hopefully, if we don't have another shutdown, that'll actually happen. I don't know. But
the shutdown business.
Just don't get me started about
I know, I can tell.
But the return on investment, that's right. Apollo was great because it was all government funded and it was a commitment by the nation, but it was a competition. And as soon as Apollo 11 landed, we've won. All right, so why are we doing this Apollo thing again? Seriously.
No, they lost the plot.
The goal is to bring the moon into our economic sphere of influence and create jobs in cislunar space. That's the point of human space exploration. You do that, then you can send humans to Mars because you leverage the infrastructure you've set up on the moon, because you're now leasing it to commercial companies and you're buying their products in order for you to go further afield. It becomes a self-sustaining way of frequent trips to Mars.
Well, you said something interesting. You said that there were 43 commercial or companies that are interested in getting stuff to Mars. What about companies that are trying to the moon?
Yeah.
What about the guys that are trying to get stuff from the moon to come back to Earth?
No, that's part of it.
Are there any minerals or resources that we could mine, and who owns the rights to that? Because that becomes complicated.
Oh, you've opened that one now. Oh dear. Yeah. There's Outer Space Treaty is what most countries have signed up to. The Moon Treaty, the US and the UK and China have not. Now,
interesting.
The Outer Space Treaty is a little opaque in how it treats resources. It's supposed to be nobody owns it, like Antarctica. But you get lawyers looking at it, they'll twist the truth and do everything else that they can to make their client look good. So the language needs to be tightened up, and that is something I know NASA is, or the administrator is definitely worried about this, and he wants this sorted out because he sees that using the resources to create jobs and create wealth becomes pivotal to the program.
Of course.
Now, is there an export from the moon back to Earth? Right now, no, there isn't. It's not cost effective to bring material back. However, nuclear fusion is the opposite of fission, where you fuse atoms together rather than split them. And the nirvana, if you like, of nuclear fusion is no toxic byproducts as we get with our nuclear fission program. Got all this radioactive waste that's going to be, Chernobyl, for example. I mean, it's a wasteland around it because thousands, maybe millions of years, you can't go in it. So helium-3 is a product of solar wind. We don't see it on Earth because we've got an atmosphere and it gets caught up and it doesn't get into the surface. On the moon, it's in the regolith, and we've measured it. Now you fuse two helium-3s, you end up with a helium-4 and two hydrogen atoms, and theoretically, it gives off a lot more energy than you have to put into it. Nobody's ever gotten a sustainable fusion reaction, although last year the Chinese came close. And China is very interested in lunar helium-3. Very interested.
Interesting. And now without this treaty and this stuff being resolved, I mean, you could go and plant your flag and say, that's my spot. I am the owner of these resources.
Yep, and now it's keep out, and then you militarize the moon, and we don't want that.
So I'm hopefully going to be interviewing Jim Bridenstine. So what are the things you think NASA should be doing if we're going to be moving forward?
I think right now NASA is on the track to a vibrant human space exploration program, because, to be perfectly blunt, what have we done since Apollo 17 came back?
Yeah,
we've sent humans to Skylab, we've sent them to Mir, we've sent them to space station. We have sent humans just off planet. All right, if we'd have kept going with the moon exploration, where would we be now? Well, it's a missed opportunity. But we have to show a return on investment, and that's where the private sector comes in. And I take if I was wearing a hat, I'd take it off to Jim Bridenstine, because he has implemented a plan that brings in that private sector. He has implemented that plan to show a return on investment from NASA's budget. It's not just a drain on the taxpayer, it's an investment in our future. And every space agency's budget should be viewed that way. It's an investment in our future. We look at the technology advances from Apollo. You look at, here's my cell phone. Thank you, Apollo. Miniaturization of electronics. All right. Satellite TV. This. Thank you, Apollo. Not Google. Google just took what Apollo did and made it better. But we could track all these advances back to the Apollo days, and that is just quite amazing.
I noticed that Bonnie mentioned something a little bit earlier about wanting a moon rock. How easy are these things to come by? And I mean, I'll be honest with you. I know that obviously the real moon rocks you don't find, and they're not easy to get. But I do have a sample of a moon rock. But it's not the kind that was fetched from the moon and brought to Earth. It was the kind where the moon visited Earth independently, and it was a piece of that.
Yeah, it got launched off the moon by an impact, so it was brought to Earth by an impact. So you've got lunar meteorites. Yeah, you can buy them online. So,
and I've got a Martian one too. Do those things interest you? I mean, do you ever take those things and have a look at them?
Yeah, I just had a paper published on Martian meteorites. So,
and how do we know that they're Martian if we've never actually physically brought any samples back?
Because what Viking did, it measured the atmosphere in Mars, and that's when we recognized that some of these inclusions, they actually had, some of the melt had gas inclusions in the Martian atmosphere. Then we looked at the chemistry of the different minerals, and they're distinctive. They have different oxygen isotopes, different iron manganese ratios. It's very detailed, but we can show that these meteorites are from the moon because we actually have samples to compare them to. We don't from Mars, but we do have data from, now we've got data from Pathfinder, we've got the Spirit and Opportunity, and we've got Curiosity that has given us data on Mars rocks. And we can start to see, oh yeah, we've got the right gas content to show that this is Martian, or it's got the right peroxine composition, or oxygen isotope composition. So we can show where they came from and show that, yeah, the impact has actually brought Mars rocks back to Earth quite regularly.
Do you have
same with the moon?
Do you have any experience with rocks that are beyond Mars, from maybe another planet?
There was a paper I was part of that thought we had a meteorite from Mercury, and the jury is still out on that one. We thought that it wasn't, because Mercury is closest to the sun, and an impact on Mercury to blow pieces back to planets to us, it takes a lot of energy. It would probably just shoot off into the sun.
Uh-huh.
But there was a hypothesis out there that this was from Mercury. We don't think it was. We think it's from the asteroid belt.
Do you follow closely the New Horizons and Ultima Thule and all these things? I mean, are you following all these new developments and what's going on in the space world, or will you just focus on the rocks that are sitting on top of the planet and what goes on there?
I prefer to have rocks in hand to study a planet. Pictures are nice. It's a first. All right. And I'm sure some clever people can take these pictures and make a career out of them. I can't do that. I need samples. So I prefer to have samples rather than just pictures. I mean, it's a phenomenal feat. So I mean, absolutely brilliant.
What is the most valuable rock you possess? Maybe not in value in money, but in something that you find valuable.
Oh, I like that.
Bonnie wants to know, how can we as private citizens, let's just have a look at that question in the chat here. It says here, how can we as private citizens support NASA to encourage our government to keep pushing forward with the NASA space program? It's a good question.
Yeah. We have to contact our Congress people. We have to, and as a private citizen, you can do that. However, what I found, and when NASA's budget was up last year, and it was March last year, I was approached by some of our commercial companies on the commercial advisory board saying that NASA's budget was in trouble in Congress because NASA couldn't justify why they wanted the lunar program. Go figure. So we wrote a letter, and I run a lunar listserv, which is an email list server, and we've got 800 people around the world as part of it. But I sent an email just to the US people, and I said, here's a letter we're willing to write. Well, we've written, and we would like you to consider signing it in support of NASA's budget. And we got, I think, 85 people to sign it. And it went to the various staffers of the various committees and was actually used to say that the community has now justified why NASA needs this budget, and the budget was passed unchanged. So, and the feedback I got was that this does work. So I think, yes, you can email me to join the listserv. That's cneal@nd.edu.
I'll send Bonnie all the details.
Yep. Okay.
That is cool. So now, going back to your most valuable prize possession, what is the one thing you do have?
14321. I have pieces of, that's Apollo 14 Breccia. Breccia is now is a big rock that contains lots of bits of other rocks, and they've all been welded together via impact. I made my career on 14321. It's the first rock I studied when I came to America, and just had another paper accepted looking at rocks from that. So that is the ultimate rock, what I call the gift that keeps on giving.
Like the Rosetta Stone of rocks.
Well, it's one of those. There are other breccias there that we now can use a CAT scan to look at the interior of to see what's there. That's going to open up a whole new area of opportunity. And there's even some samples that haven't been opened from Apollo. And there's a call that we propose to actually open those and start studying them. So yeah, there's three drive tubes that are unopened and have been kept sealed since they were collected.
So when you said there were several hundred kilograms of rocks that were brought back from the various Apollo missions,
right?
And there are still rocks that haven't actually been examined yet,
right?
Many decades later, 5 decades later, why would that be the case?
Because we've been waiting. These were collected to understand the volatile contents of the regolith, solar wind implantation. They were collected in shaded regions of the moon, behind boulders, and we didn't have the technology to be able to do it properly. We do now. So now the volatile's taken on a whole new light, given that this is now a resource.
So what is the best technology out there at the moment that you think is going to make groundbreaking findings in rocks that we've already known about, but now all of a sudden with this new technology, almost like, you know, the kind of impact that DNA testing has had for the FBI? You know, there was this whole story of we're trying to interview a woman who is a genealogist,
right,
as opposed to a geologist.
And
this genealogist, she has become quite famous because she's been cracking some of the FBI cold cases that have run cold. They were unable to do anything about it because in genealogy, people are now using DNA testing. And all of a sudden, these people were able, so they took some of the DNA samples and they were able to find 2 people in a family tree that were in common. And all they had to do was find the person that was in common to those 2 people, and they could actually identify potential suspects, which the FBI were never able to do.
Right.
So what sort of new technology is around now or hoping to be developed that will change already what we know about the current rocks that you have?
Well, being able to analyze different sections within a given mineral for their volatile content, for their isotopic content. We couldn't do that during the Apollo period, but we can now. We now have microbeam technologies to be able to do that, which is revolutionizing the way that we actually pull apart these rocks. We happen to think, and we have a paper out under review, that some of the ages that have been produced using different radioactive schemes are actually wrong, because they're using minerals that come from mixed rocks. They're not actually all from the same event that actually formed them. And we can now, by looking at individual minerals within those, we can show that, because we have the microbeam techniques to do it. We now have the sensitivity of our gas mass spectrometers to be able to pull apart the compositions of very minute traces of gas. So that then becomes another way to look at these unopened samples that we couldn't do before. So we have a whole plan set up to analyze one of the Apollo 17 drive tubes, and Harrison Schmitt is part of our team. He was the first geologist on the moon of Apollo 17, and he tells us all about when he collected it. It's quite amazing. So we have a new opportunity. We have new samples to look at. But what we now know since Apollo is that they landed not in the ideal places. We now know that the Apollo collection is not representative of what's available on the surface of the moon. So we've actually devised a map of where we need to go back to sample, robotically or otherwise, to actually understand the moon a lot more than we do now.
Wow. I know we've only got about 5 minutes left. It's gone like this. What I'm fascinated about is that obviously, you know, you've got your intentions and what you'd like to learn about the moon and Mars, and then you've got a crazy South African, or ex-South African, Elon Musk, who is just like other innovators moving forward with their own agendas, but obviously for the benefit of space exploration, whatever it is. What do you think is going to be the turning point in the space world that is going to make people see space in a different way? Because right now, I think people are a little bit complacent, although NASA has been doing some major social media marketing, and they've made some interesting announcements, and rocket launches are big, and people are excited about NASA.
Yeah.
But the commercial space flight industry is going to take off soon. And that means people like you and I will be able to afford a ticket just to spend a little bit of time floating around in space. But Elon Musk is not happy with that. He wants to go further, and he's looking at colonizing Mars, if you could call it that.
Yeah.
What is your gut feel on the big things that's going to change the space industry?
The thing that we have are people who don't fear to dream big. NASA doesn't do that anymore because it's too old. As Jack Schmidt says, if you look at the average age of a NASA employee during Apollo, it was 28. It's not that now. So I made a statement the other day that I thought compulsory retirement at 50 for NASA employees would be a good thing. Then you bring the youth in that have new ideas, and we don't get, well, the way we do human space exploration is Apollo. No, that's not the way you do it. That's the way you don't do it. And we've got it, and that's where these Jeff Bezos and Elon Musk and Masten
Richard
Space
Branson,
and Rocket Labs.
all those guys.
Richard Branson is more of a, let's go up into low Earth orbit and faff around up there. These other guys want to go to the moon, or they want to go to Mars. They want to go beyond. So I think that it's good to have these aspirations, but then you have to understand the dangers and the challenges of doing that. That's what's going to drive technology development. That's what's going to drive cures for osteoporosis down here. That your skeleton's going to dissolve if you're on your way to Mars for 6 months in microgravity. All right. So when you get there, what, you're going to be a soggy bag of flesh? I mean, hopefully not. What is the radiation going to do to you? Are you going to be dead by the time you get there? How do you protect yourself? Well, one way to do it is put a meter thick sheath of water around your living quarters. That's a lot of weight, but if you got it from the moon, it's only 1/6 G. You could. There you go. There's your radiation protection, and maybe there's a way to do that. So right now, you've got to think this through in terms of the challenges. We want to go colonize Mars. He makes great PR with that, and I'm standing there going, yeah, okay, you go. Then you'll figure out what the issues are. You don't send people, we got people that say, oh, well, I'm willing to go on a one-way trip to Mars. Okay, all right, I'm sure you are. But what you're thinking is we're going to live and die on Mars. You're going to be dead by the time you get there right now. And those technologies need to be well thought out before we start putting humans in the critical path.
Sure. Well, I mean, we've kind of run out of time. So are there any parting messages that you want to give younger people, especially from a STEM point of view? First of all, encouraging them to get involved in geology. Why is geology? I want an elevator pitch. I want to know, why is geology the science that they should be pursuing? And second of all, maybe a message to young people in terms of, what you would like them to know about the space world and where we're heading.
Okay, well, geology, number one. Reason why you should get into geology is there are so many different opportunities within geology. It is a science that contains all other science. It contains physics, biology, chemistry. It contains engineering. It contains all of those things, as I'm finding out. It's led me down a path to look at space exploration. So now I'm cracking on about rocket engines, and I'm having to do a lot of reading because rocket engine, what the hell is that? I have no idea. So you're always learning, and that's the thing about geology. It can lead you on a path that will allow you to really explore the environment that we live in, or maybe an environment that we want to live in. So I think that we have to hold on a minute.
No problem.
Have to take that. Hold on a minute.
Okay, you can.
Hello?
This is what we love about live broadcasts.
Can I call you right back? I'm on a teleconference right now. All right. I'll call you right back. All right. Sorry about that. That's the 5th time he's called me.
No, he definitely wants to get hold of you. Okay, and then the last parting information that you would give to young people.
Did I finish that? I mean, to me,
well, you were talking about that obviously geology is all encompassing, and it involves many like multi-disciplines and that type of thing.
Right.
And obviously you have to be passionate about it.
Oh yeah. I mean, that's and the thing I would say to young people is life is too short to do something that you don't like. So find something you like, and I've been really blessed because I've never worked a day in my life.
I know the feeling.
You do what you love, you never work a day in your life. And so I've been a very lucky chap because I've followed my passion. And it's true. What I find, because I have kids and grandkids, that sometimes figuring out what your passion is difficult. I was very lucky. I found out, 4 or 5 what my passion was, and I'm now a bit older than that. And this is now it's just been a lot of fun.
27 plus that.
Yeah, there we go. Right.
And then your grandchildren, I mean, are they interested in these things? I mean, how do you find
one maybe. But
last question. When you travel overseas, do you take an empty suitcase and bring rocks back with you? And how do you get them on the plane?
Okay, number 1, no, I don't, because I mail them back. It's a lot.
So you've clearly done this before.
Yeah. Oh yeah. I had the whole post office in Caracas out to watch me mail back 5 cases of rocks that I collected because that was basically 3 months worth of salary for them that I was paying for the rocks to come
just
back.
For the postage.
Just for the postage. And because the hyperinflation, I had everything wrapped up, but then I had to wrap the stamps around it and overlap them so just the denomination was shown in order to get them back. So that was an adventure. Yeah.
All right.
Yeah.
Well, I know you've got other calls and you've got other stuff to do. So, Clive, thank you so much for giving up of your time. I know that the team at the Humans to Mars Summit will be delighted. We're going to be sharing this, obviously, with a lot of young people because we want to get them excited and enthusiastic about geology and, in particular, STEM as well.
Yeah.
And, of course, botany. And we had a whole range of people from Russia, India, Nepal, the USA, South Africa, and a couple of other countries that popped in and were watching it live as well.
Good.
And then people who missed it now will be able to watch it as well. So thank you.
And tell Bonnie I will certainly rock on.
Excellent,
sure.
excellent. And then we just need you to do one last thing. You have to smile and look at the camera so we can get one photo.
Oh, you want a photo of this?
Because what happens is when YouTube picks a photo, they always pick one of you while you're in the middle of a conversation and like that. And then we want to make sure we got a good one.
That's just normal. That's all right.
Okay. So thank you. Thank you so much.
No worries. I'm happy to do it. I thoroughly enjoyed it. And good luck to everybody.
You're a star. Thank you. And bye-bye.
I don't know about that, but bye. Bye.